If Yellowstone explodes tomorrow, you won't hear it first. You'll feel it. The ground will groan like an animal under the weight of its own rage. And before you even look up, the sky will already be falling. Across the plains of Wyoming, the mountains of Montana, and the quiet towns of Idaho, morning will turn to midnight. The heart of America, the highways, the farms, the cities that never sleep, will be silenced under a rain of ash. 3,000 kilometers away, the black snow will still be falling, drifting over Chicago, New York, even Washington, D.C., as if winter itself had turned against its maker. Satellites will lose their signal. Flights will vanish from the sky. Power grids will hum one last time before they go dark. This is not fiction. It's an overdue event by about 600,000 years. And when it happens, the United States, the most powerful nation on Earth, will face something it cannot bomb, bribe, or bargain with: the Earth itself. Long before there was a nation called the United States, before highways carved the plains, before even humans walked these lands, the Earth here was already alive. 2 million years ago, in what is now the calm, open wilderness of Wyoming, the ground rose and broke apart. A single eruption, so vast, so violent, that it carved out a crater 70 kilometers wide. It was the Huckleberry Ridge eruption, and it ejected enough ash to bury the entire state of Texas under 5 feet of dust. The sun dimmed. Seasons disappeared. What followed was not years, but centuries of volcanic winter. The land healed. Forests grew again. But beneath that new green skin, the monster only slept. 1 million years later, it woke again. This time at Mesa Falls, another eruption tore through the earth, smaller but still apocalyptic by human measure. Rivers vanished, mountains melted, the sky turned gray for generations. Then, 640,000 years ago, came the last great breath, the one that shaped the Yellowstone we know today. The Lava Creek eruption, the third and most infamous, turned an entire mountain range into a collapsed crater, the Yellowstone caldera. The explosion was 1,000 times more powerful than Mount St. Helens. Ash from it rained down over half of what is now the continental United States, from California to the Mississippi River. Imagine standing in Nebraska or Kansas and seeing the horizon vanish in a storm of falling stone. That was Yellowstone's last roar. Beat of silence, and then it went quiet. For 640,000 years, the mountain has slept, but it never died. Even today, the ground above its ancient scar breathes. Geysers hiss, lakes boil, the crust is rising. About 2 inches every year. It's a slow inhale, a warning in plain sight. Scientists have mapped the magma chamber beneath Yellowstone, a colossal reservoir stretching 90 kilometers long and 20 deep, big enough to fit the entire city of Los Angeles inside it, twice. And though it slumbers beneath fields, forests, and tourist trails, its heart is still hot enough to melt stone. So when you walk through Yellowstone today, through its steaming valleys and sulfuric pools, you're not walking on solid ground. You're walking on a loaded gun. The question isn't if it will erupt again. The question is, when the mountain wakes, will we be ready to listen? A volcano is violent, but a supervolcano is something far more ancient, far more patient, It doesn't rise like a cone or rumble in warning. It sleeps beneath valleys, under forests and rivers, biding its time for hundreds of thousands of years. Beneath Yellowstone lies a chamber of molten rock nearly 90 kilometers long and 20 deep, a buried ocean of magma capable of changing the face of a continent. But here's the strange part. You can stand right above it, watch the bison graze, hear the geysers hiss, and never realize you're standing on a loaded gun. Scientists measure eruptions using the Volcanic Explosivity Index, or VEI. Mount St. Helens in 1980 scored a 5. Krakatoa in 1883, a 6, loud enough to be heard 3,000 miles away and powerful enough to shatter an island in two. But a supervolcano, that's a VEI 8, 1,000 times stronger than St. Helens, 10 times more devastating than Krakatoa, an explosion that doesn't just destroy, it rewrites the planet's atmosphere. When Yellowstone last erupted 640,000 years ago, the blast threw 1,000 cubic kilometers of ash into the sky, enough to bury Texas under 5 feet of stone dust. The mountain didn't rise. It collapsed inward, leaving behind the massive scar we now call the Yellowstone caldera. Unlike the volcanoes that ring the Pacific, Yellowstone doesn't sit on a fault line. It sits on a hotspot, a mantle plume, a column of molten rock rising from the deep earth, burning through the crust like a slow-moving torch. A mantle plume is a column of very hot rock that slowly rises from near the Earth's core. As it moves upward, the pressure decreases and the rock begins to melt, forming magma. That magma feeds the volcanoes and geysers we see on the surface today. Most volcanoes form where tectonic plates collide or pull apart. But Yellowstone sits in the middle of a continent because the heat comes from below, not from plate movement. This same kind of plume also created the Hawaiian Islands and Iceland. For millions of years, this plume has carved a fiery trail across the continent. Idaho, Oregon, and Nevada, leaving behind dead craters and black plains as quiet reminders of where it once breathed. Every few millennia the pressure builds. Gases trapped within the magma increase. The crust above begins to bulge and fracture, until one day, the Earth can no longer contain its own heartbeat. We call it a supervolcano because we have no word large enough for what it truly is. A planetary event, a reset button in the history of life. If Yellowstone erupts again, it won't start with an explosion. It will start with signs, small ones, the kind we almost miss. In the days before a major eruption, seismic instruments across Wyoming, Montana, and Idaho would begin to record hundreds of small earthquakes every hour. The ground around Yellowstone's central caldera would start to rise, not inches per year as it does now, but several inches per day. Geysers would behave erratically, or stop erupting altogether. The hydrothermal systems, the surface vents where pressure is usually released, would seal themselves with mineral deposits, trapping steam and gases underneath. To the casual visitor, Yellowstone might look the same, but underground, the pressure would be climbing toward a critical point. Scientists estimate that the magma chamber beneath Yellowstone holds over 50,000 cubic kilometers of molten rock, most of it semi-solid. But enough liquid magma exists to feed an eruption large enough to blanket half the United States in ash. Once the internal pressure surpasses the strength of the rock above it, the crust would begin to crack. Superheated gas, magma, and ash would rush upward at supersonic speeds. first eruption column would likely rise more than 30 kilometers into the atmosphere, almost 3 times the height of commercial airliners. Within minutes, the sky over Wyoming and Montana would turn black. The explosion would instantly vaporize everything within a 50-mile radius: forests, rivers, towns, wildlife. Temperatures around the vent could exceed 700 degrees Celsius. Within the first hour, volcanic ash would begin falling across neighboring states: Idaho, Montana, Utah, Colorado. Within a single day, most of the western United States would be covered. Jet engines can't operate in ash. Every commercial flight across North America would be grounded within hours. Communications satellites could be disrupted by charged particles in the stratosphere. The immediate zone of devastation would stretch for hundreds of kilometers. But the true disaster would be global. Millions of tons of sulfur dioxide and fine ash would be injected into the upper atmosphere, forming a reflective haze around the planet. This layer would block sunlight, lowering global temperatures by 5 to 10 degrees Celsius for years, a phenomenon known as volcanic winter. We've seen smaller versions of this before. In 1815, the eruption of Mount Tambora in Indonesia, a volcano 1/10 the size of Yellowstone, caused the year without summer. Crops failed across Europe and North America, leading to global famine. The Yellowstone event would release over 100 times more material into the atmosphere. Even nations far from the eruption would feel its effects. Monsoon cycles in Asia could weaken, leading to droughts. Temperatures in Europe would fall dramatically. In some regions, snow could persist through summer. The immediate death toll might reach tens of millions, but the real cost would come in the months that follow, from hunger, disease, and exposure. When the skies finally cleared, the United States would be unrecognizable, a continent carved by fire and ash. New rivers would form. Old cities would become fossils beneath volcanic dust. From orbit, one scar would stand out, a vast caldera stretching across the heart of North America. Yellowstone isn't an exception in Earth's story. It's part of a larger pattern scientists call the mass extinction cycle, moments when life on Earth is reset, not erased. Over the past 540 million years, the planet has gone through at least 5 major extinction events. The first, about 440 million years ago, froze the oceans. The second destroyed most marine species. The third, the Permian extinction, nearly ended life itself. The fourth wiped out the dinosaurs. And the fifth cleared the way for mammals and for us. Each extinction had a different trigger: massive volcanic eruptions, asteroid impacts, runaway climate change, the loss of oxygen in the seas. Different causes, same result: a biological reboot. Supervolcanoes like Yellowstone belong to that same family of triggers. They erupt rarely, but when they do, they alter global temperature, chemistry, and life for centuries. Yellowstone's last eruption cooled the planet. The Toba eruption in Indonesia, 74,000 years ago, may have reduced the entire human population to just a few thousand. This is what mass extinction theory teaches us. Earth is not a stable system. It cycles between creation and collapse. Stability is just a pause between resets. If Yellowstone erupted again, it wouldn't wipe out humanity, but it would shatter the world we know. Agriculture, trade, climate, all would realign. The lesson isn't fear, it's humility. We are the survivors between catastrophes, the beneficiaries of the calm between corrections. The Earth doesn't belong to us. We belong to its timeline. Civilizations rise in the quiet between eruptions, each believing they are permanent. But geology tells a different story. Everything we build stands on a planet still under construction. Yellowstone will erupt again, maybe in a century, maybe in 50,000 years. It's not punishment, it's process. The Earth continuing its rhythm, and when it does, life will adapt again. Because the real story of Earth isn't survival, it's continuity through extinction. If you've journeyed with us through the story of Yellowstone, through time, through fire, through the Earth's own pulse, then stay with us, because this planet has more stories to tell. Subscribe, and let's keep uncovering the world beneath our feet.